You had one radical inequality on your quiz, and it's number 13. Keep in mind what our entire concept is on radicals, whether inequalities or equations, isolate one. So I'm going to go ahead and isolate the 9x plus 19, and that has to be greater than 3 plus the square root of 6x minus 5. So we're going to square both sides to get rid of the square root on the left, and when we square both sides, we square a binomial on the right. So we square this binomial, so the squaring will undo our square rooting, so they are inverses. So 9x plus 19 is what we get on the left side. It's greater than. On the right side, we square a binomial, and you square the first, double the outside inside, so that's plus 6 times the square root of 6x minus 5. Then we square the last, and that square and the square root will undo it. They're inverses, so just plus 6x minus 5. Now that still leaves us with a radical in our equation. We want to isolate this term with the radical. So do a little cleaning up on this one side. So 9x plus 19 has to be greater than 9. Well, let's go ahead and clean it up. As I said, we're going to take our 9 and subtract 5. That's going to be 4. Plus 6 times the square root of 6x minus 5 plus 6x. And then we'll move over our 4. Our 4 over here, we subtract will give us a 15. We'll go ahead and subtract our 6x from 9x, so now we have 3x plus 15 has to be greater than 6 times the square root of 6x minus 5. Now I'm not in a big hurry to move that 6 over, because if I divide by 6, I'll create fractions on the left side, so I'm going to square it in this present form. So I'm going to square the left side and square the right side. Again, the purpose of squaring is to undo our radical square root. If we square a binomial, we'll get 9x squared. This is 45, and then doubled is 90x plus 15 squared is 225, greater than. Now we square our 6 is 36, and we square our square root, undoes that radical, so it's 6x minus 5. So we'll have 9x squared plus 90x plus 225 has to be greater than. 36 times 6 is 216. X, and 36 times a negative 5 is a negative 180. And now at least we've cleared out all of our radicals. And what we're down to now is a quadratic equation. So we're going to get everything on one side. 9x squared. We're going to move the 216x to the left, so it's going to be a negative 126x. And I'm going to add the 180. So if I add the 180 over there, we get positive 405. That has to be greater than 0. Now I'm not liking my chances in finding the factors of this, so I'm going to go ahead and go straight to the quadratic formula. So that means we can find the values of x if we take 126, the opposite of b, plus or minus the square root of. And that's going to be 126, or negative 126 squared, then minus 4 times 9 times 405. So we're looking at some decent sized numbers here. All divided by, or each divided by, I'll just go all divided by right now by 2 times a, which is 18. So I went ahead and I did some of those calculations to try to speed this process up a little bit. I took the 126 squared minus 4 times 9 times 405, I got a negative, or I got a positive 1,296, so it's 126 plus or minus the square root of 1,296, that's all over 18, and then I went ahead and took the square root of 12,096, and lo and behold, that thing was a perfect square. So at least they were kind enough to give us a perfect square on that one. And now we're going to go ahead and do our adding and subtracting to get our two zeros of our function. So I'll put this away, and now we're going to take 126 plus 36 divided by 18 to get that solution, and then we're going to take 126 minus 36 divided by 18 to get our second solution. So when we do our addition, what we end up with is 162 all over 18, and 162 eighteenths is 9. And then we do our subtraction, what we end up with is 90 eighteenths. And if we do our simplification on that, that is 5. So now I've got the zeros. Now what we need to do is use our interval line test. Give me just a second, I got a messenger. Okay, sorry for that interruption. What I had to do is take care of a little business. So Now what we have are our two zeros on the number line at 9 and 5. But I want to come up here to my original equation. And I want to sketch this 9 and 5 on my number line. So here's 9 out here, 5 in somewhere in there. And with radical equations, we always have to be worried about the domain, at least concerned about it, and address the issue of, are there some possibilities out here that we can't use because of our domain restrictions? So what I want to make sure is that 9x minus or plus 19 is greater than or equal to 0, which makes 9x greater than or equal to negative 19, which means x has to be greater than or equal to negative 19 ninths. And that is basically x has to be greater than or equal to, yeah, it's decimal, about negative 2.1 approximately. So this is one. And we also had another radical that we had to contend with, and that is when we have the square root of 6x minus 5, so it's just 6x minus 5. Let me try writing that again. So I want to make sure that 6x minus 5 is greater than or equal to 0. Otherwise it's not defined. So we definitely don't want to use any numbers that are smaller than a negative 2.1. It's undefined. Let's see if this adds on any restrictions. So that's going to be positive 5. So x has to be greater than or equal to 5, 6. Now, if I compare these two restrictions on our domain, this function was never going to be defined unless we give it an input that is greater than or equal to 5, 6. So this one is never going to come into play because this restriction will have precedence. Remember, we always take the more defining restrictions. So I also want to consider where this function is even defined, and that is only when x is greater than or equal to 5, 6. So I want to look at these three intervals in particular. There's the fourth interval here. This first interval, I guess I go from left to right. Second, third, and then the fourth interval. So when I get done with this thing, what I can do is I can put in a number like 10 and see what kind of an answer I get. And I could go ahead and I guess I'll just put it back up in here. All I need are signs anyway. 9 times 10 is 90. 90 plus 19, that's over 100. So this is a number that's generated a number like 10. And let's see how exact I have to be. And then 10 times 6 is 60. 60 minus 5 is 55. So you take the square root of 55, and 55 has got to be a number. If you think of 64 as a perfect square, it's an 8. So it's minus an 8, and I want to subtract that 3. Is that going to be greater than or less than 0? Let me stop just a second. I want to make sure I'm going to get this part right and I have to redo. Okay, what I want to be careful of is in my calculations. So what I went ahead and did when I went away here is I went in and put in those calculations to see what my number would be. I chose 10, which is relatively close to 9. I probably would have been smarter to use a larger number such as 20 or 30 because it's in this range where it goes to infinity. But if I plug all those in, what I ended up with is, and this is the calculation, 9 times 10 plus 19 minus the square root of 6 times 10 minus 5. And then I actually went, I'll show you the whole thing. And I said minus 3. I wanted to put minus 3 so I could tell if it's greater than or equal to 0. And like you saw, it was 0.02. So it is greater than 0. So on this side of that number line, we would get in our fourth region or interval, it's positive. And I'm not positive why I'm doing it this way. I know it's 100% consistent. It can be done this way. But I should see some alternating in here. It's positive, negative, and then it should go positive, negative. But remember, we can't use any numbers in this first interval because it's going to make our one radical undefined. We can't even use numbers less than 5, 6. So we want to get rid of interval number 1. And the reason I was saying I don't even know if I'd use my interval line test because I had this quadratic equation that I solved, and I had two zeros of that function, which were at 9 and 5. And then since it was a positive 9x squared, I would know that it is a smiling curve in between this 9 and 5, which means outside it's positive, inside it's negative, and then outside here again it's positive. And since we're searching for all of the numbers and kind of clean up something here, what are the solutions that will make it greater than or equal to 0? I have to analyze that part of my graph, and from that I can interpret anywhere from this negative, this positive 5, 6, it's exactly 0, so I can use 5, 6. And I can go up to and include 5 because that gives us 0. But I want to union that with the next part, which is all the way from 9, which is, again, a square bracket because we can use that. That's equal to 0, and that's just fine to infinity. So this is my solution set for question number 13.